Good, good. So, have you started recording? Have you started recording, Gridhar? All right. So, do you have any questions for me at this point? Yes, go ahead, Gridhar. So, if you have any questions before we start our discussion, we can clear that now, and then we can continue our discussion. Yeah. Yeah, go ahead, Gridhar. All right. The question which Gridhar has asked is, okay, so how does Cassandra versus Spark architecture looks like? Okay, so let me just go to Google Drive. All right, and there was the all right. So we will say Spark, and what's the date today? Today is 10 January. Okay. All right. So the question is, how does Cassandra versus Spark architecture looks like? First, few things we need to keep in mind. Cassandra is a DB database, meaning it provides a place to store data, while Spark is an execution engine. Okay, meaning Spark does not provide a way to store data, but we can give our program to Spark. It can connect, and Spark will run that program, and our program will say uh, how to load data, where to load data from, and how to uh, do the overall processing. Okay, so Cassandra is a DB and Spark is an execution engine. So in Cassandra, you have similar to Cassandra and Spark. The similarity is both run on multiple nodes. Okay, and Cassandra, the means of processing is in the form of Cassandra query language. Okay, so you can think of Cassandra as if it's a place to store data, while Spark is an execution engine. All right, so it'll be difficult to compare the architecture, but this difference makes a very big difference between the two. So Cassandra has multiple uh, nodes on which we install Cassandra, and out of which one of them is selected as master automatically. Okay, and while in Spark we basically make the whole cluster up and ask for execution. All right, so this is a kind of little different comparison. Okay, all right, so all right. All right, does it make sense to you, Gridhar? Any other question we have as of now? All right. So a question from Rahul is, can we use Cassandra as Spark data store? Yes, definitely. Okay. So yes, we can use Cassandra as the Spark's data store. And again, Spark will take care of the data locality in case of Cassandra. If I understand correctly, Spark tries to identify the node on which the Cassandra is keeping the data and will try to delegate as much work as possible to Cassandra itself. All right, Giridhar's question is, does this require Yarn and other tools? This as in Cassandra requires Yarn and other tools? Yeah. So does this require Yarn and other tools as discussed? So not really, not really. If you have Cassandra and you can run Spark, you can run Spark. Okay. So question is that do we need question is do we need Yarn if we need to read data from Cassandra in Spark? Is that your question? The straight answer is no. Okay, because the Spark can directly talk to Cassandra even if running in standalone mode. Okay, because if you think about it, all Spark requires is a way to connect to Cassandra, so which does not require any interference from Yarn. Okay, a question from Rahul: what is the advised or widely used data store for Spark, Cassandra or HDFS? I'm not so sure about this because I don't have the statistics, but Cassandra is far less adopted as compared to HDFS or HBase. Okay, so what I've seen mostly is people using HDFS with Spark. All right. All right, but Spark in general has been very suitable for doing all kinds of processing from all kinds of databases. data from all kinds of databases. All right. So should we carry on our rest of the discussion? Do you have any other questions at this point? Sachin's question is, what if you were to use only structured data? Would Cassandra be better option over HDFS? Yes. Okay. So then, so honestly, then the problem would be HBase versus Cassandra. Okay. Because when we say structured data, we are talking about data where we know the structure of it. And mostly when we say structured data, we are talking about tabular form of data. And while for manipulating tabular form of data, the file system does not do the justice. We will have to edit the files. Okay, we'll have to append to the files, and we will have to um, all right, we'll have to append to the files. It'll be very difficult to modify, update the tabular form of data using a file using a file. And therefore, HDFS is not suitable for handling structured data. Okay, specifically if we are trying to alter or modify such kind of data. All right. All right. There's a question from Rahul. Question is, can you give a little insight about HBase? Is HBase a data store or just a way of querying HDFS? It's a proper data store. Okay? It's a proper data store. If you allow me for a minute, I can give you a demo. I think that will give you a bigger sense of idea. Okay? Okay? So it's a proper data store, and where is the, all right? All right. So basically, it's a kind of data store where you can store millions of rows and millions of columns. Okay. So it's a kind of that kind of data store where you can store millions of rows and millions of columns. All right. And the only difference you would notice with HBase is that as you add as you add rows to the data, you can also add columns to the data. So you can keep on adding the rows. Similarly, you can keep on adding columns to the data. Okay. So that way, basically, the table in case of this thing, I think, how can I make it look like nice? Okay. So let's say we start with this kind of table. It has got, say, three columns. In HBase, you can add as many columns as you want at a later point of time. Okay, you can add as many columns as you want at a later point of time. So that's a kind of, most of these databases, when we talk about the HDFS or when we talk about, say, Cassandra, MongoDB, they allow modifying data as and when we want. So we can keep on adding more and more data and more columns as well as rows in HBase. Okay. All right. So that's something important to know about most of the NoSQL. Most of the NoSQLs allow you the flexibility of adding columns, flexibility of allowing you to store non-relational data as well. Okay, and the rows are always identifiable with a unique ID, so that so that you can always uniquely identify each row, each record you can identify, so that you should be able, so that the database can store the row on any of the node, because all of these databases run on multiple data nodes. Okay, all right. So that was a brief idea about HBase. Is that good enough, Rahul? Great, great. All right. Now there's a question from How. I knew we can use Spark SQL / Hive to query structured data. And what is the underlying storage, HDFS or other databases? Mostly HDFS if we are querying using Hive. Okay. But interestingly, Hive also provides connectors to the databases like HBase and to the third-party sources such as Amazon S3. Okay, so although Hive started with querying the HDFS files as an alternative to MapReduce, so Hive started as an initiative to avoid writing MapReduce and instead query the data using SQL. But then slowly, more and more connectors were added to Hive. And now you can actually query S3, you can query HBase, etc. So that's the interesting part of it. So while on one hand, Spark SQL and Hive, all of them provide you a way of querying the data using SQL, and this data could be stored at many sources. All right. Did I make sense, How? All right, great. All right, brilliant set of questions. So moving on. Good, good. Now, I think we talked about take. Yeah, we were here. All right. So the important part to know about an RDD, okay, that every time we call an action, okay, so every time we call an action, entire RDD must be computed from the scratch. Okay, so when we say filter this particular RDD or do the flat map on an RDD, what exactly are we trying to do is we are trying to say that we are trying to say to Spark that hey, make a note of it. All right, and once we are done with all of the transformations, then we call an action, and this action causes all of the preceding or all of the depending transformations for the execution. Okay, so every time we call an action, entire RDD must be computed from the scratch. Okay, and every time D gets executed in this particular example, ABC would be run. Okay, the only case is we can say uppercase lines dot cache, which means uppercase lines will be cached into the memory so that it doesn't need to be recomputed from the scratch. Okay, that is another way of looking at RDD. There are many kinds of RDDs, and one of them is cached RDD. So you can cache an RDD in the sense that it'll bring the data and keep it ready for you. Every time you make a call, you want to access something from a particular RDD, it would not start its evaluation from the beginning of the computation. All right. So let's say you realize that these few lines are something which is going to be very much used again and again. So what you do is you cache the few lines. You cache the few lines RDD. Okay, that means when we run uppercase lines equals to few lines dot map and then uppercase dot count, only this one will take time. This will not take time. This will not take time. All right. So those are the interesting optimizations for Spark. Okay. Now when we cache, it could be in the memory, it could be partially in the memory and spilled over to the disk, or it could be completely into the disk. So there are many kind of ways in which we can cache an RDD. Cache is more like that saying that now we are preparing the whole data and it's available for the further computation so that we don't have to recompute. Also, in case even a cached RDD fails, it will recompute from the beginning and again cache it on any other node. All right. So when we call an transformation is not evaluated immediately, it helps Spark to optimize the performance, and similar to pig and link and etc. If you remember pig, where if you have gone through the Hadoop trainings, so the moment you say dump, it basically evaluate all of the depending tasks. So when we say dump, all the data sets are computed. All right. So instead of thinking of RDD as a data, think of it as instruction given to instruction of how to compute the data. All right. Now here is an example of lazy evaluation. Okay. Imagine that you have two functions. One is map1, map2. Map1 is doing strip and map2 is doing translation to uppercase. All right. So what we are trying to do is lines equal to sc.text file, and then we are saying lines one equals to lines.map, and then the map function. Then we are saying lines2 equals to line1.map, and then the map2 function. Now if you see, if you look at it, what we are trying to do is we are trying to run two functions, map1 and map2, right? And And both of them could be clubbed easily together if we look at it. So the moment we call line2.collect is going to run this one, and this one. Correct? Now, when Spark looks at it, when Spark prepares the DAG, it sees that there are two map functions, which gives it two adjacent to, or you can say, two what do you call, two uh, neighboring map functions. So it gives an idea to Spark that these two functions could be clubbed together. Instead of running this in two separate phases, it converts them together and run those two functions in a single shot. Okay, so that's a benefit of having the lazy evaluation. Imagine that had this been executed immediately, then this will get executed, then this will get executed. That means the function computation is happening twice. Okay, so whatever data transport happens will happen twice. Okay, therefore, these kind of optimizations are made possible due to the lazy evaluation of an RDT. Okay, does it make sense what this optimization kind of things? How? Arpan, Haur, Rahul, Sachin Sekhar, and Gridhar. Do these things make sense to you? All right, great. Keep asking, keep letting me know if there is something which is not clear. All right. All right. So there are two, since we are passing the functions to our map or reduce functions in Spark, there are few things you have to take care of. Okay. One is by the way of inline functions. We call them lambda functions. Lambda functions are there in Java as well as Python. And objective of lambda function is to make the computation inline. Okay, to make it inline so that you don't have to define a function before executing it. Right? So you can see that it's an anonymous function. The good part about it is you don't have to define before the statement. The bad part of it is that in case you have to use the same logic elsewhere, you can't use it. There is no name for this logic. It says lambda s, which means we are starting a lambda function where the first argument of the function is s. Colon means the starting of the declaration, and what it does is it returns error in s. Okay, you can think of there's a return statement here, which means if the error is occurring in this particular string which is being passed to the function, it will return true. If error is not occurring in this string, it will return false. That's what it is trying to do. This is good if we are trying to look for a keyword error in the, we are looking for only the strings in RDD that contains a keyword called error. Okay? All right. Now, so Sekhar's question is with respect to the lazy evaluation. So the map 1 and map 2 will not run subsequently one after another. Instead they will run together. Although the order of the evaluation will happen in the same way, in the sense that value equals to access strip, this is from this part, and then return upper value. So both of the map 1 and map 2 has been combined together, although the order remains same. Just that they will not execute separately in two separate execution. This is just an example of optimization. All right. So first method of passing a logic to the filter method or any other transformation is in the form of lambda function. Second is in the form of creating a separate function. You can see that here we are creating a function with the name contains error, and we are saying that there will be an argument called s, and we are saying return error if return true if error is found in s, otherwise return false. Okay, so it basically will filter the messages for the key which contains only the error keyword. Okay, now there are few things you have to keep in mind while passing the functions to Spark. You have to be a little careful, right? And this is a big mistake which all of us make. In Python also there are classes and there are instance methods. Okay, class is something which we have not covered in our discussion. Okay, so class is basically similar to C++ or Java class, where we say class and the class name, and then we say this is the basic the one which it is extending. It's saying object, which means it's extending the top level object. And then we are saying init, it means it's a constructor. Okay, and then these are the functions. These are the functions. All functions, all instance functions of a class have a keyword called self. The self is pointing to the instance of the object. Okay, it will give us access to the local variables of the class, member variables of the class. Okay, so we have these three methods here. So if we try to use one of these functions, okay, if we try to use one of these functions together with RDD, what would happen is it will start sending the whole object to Spark. And if your object is really huge, then what would happen is the transport of the object might become a very big bottleneck. And this happens all the time. We start sending, okay, we start sending the what you see here is there's a member variable called get matches function references, and first argument which we are sending to this is an RDD. We are saying rdd.filter self.isMatch, and what does it do? It basically what we're trying to do is we are trying to pass an RDD to this function. Okay, we're trying to pass an RDD to this function, and then on an RDD we are passing the filter. And what you see here is, so eventually we end up passing the self object in one way or the another. So this will lead to transporting the whole object of search functions to the Spark, which is going to be a big headache. So do not try to mingle your class objects with Spark RDDs. Try to keep the two separate. Try to trim down your functions. If you are passing a reference of a function, then try to keep it separate. Do not try to wrap the objects, and do not try to send the instance variables to the functions. Okay, so keep that in mind while we are sending it to Spark. So for example, this one, what you can do is here get match not reference here. Instead of passing the self object here, what we could do is we could just extract a variable from self and then pass only that part to RDD, only query. Now the self does not go there. So keep these things in mind. So to keep the whole object away from rdd.filter or any of this, because these functions make sure that it takes the whole object and it doesn't fail. It's good in a way that it won't fail and it will take all the declaration. It's just that it will make it really heavy. All right. All right. Arpan's question is, function body is followed by lambda keyword? No, function body is followed after the column. Here. All right. There are a few more questions. A question from how is, how about passing static function? Yes, but it's still, again, when you pass a static function, do not pass any instance object like this or self. Okay? Passing a static function is absolutely okay. All right. There's a question from Arpan. Question is, so it's like, is it like extract the object's member in a separate variable and pass that instead of instead of the whole object. Yes. Okay. So Arpan, did you get the answer regarding lambda one? Great. Great. All right. How did I answer your question? Great. All right. So moving on. And similar to that, let's say, so Scala is very similar, somewhere between Python and Java. Okay. In Java, you have to declare the data type of variable on the both the sides, meaning while declaring a variable as well as while creating a variable. So basically, in case of Scala, you do not have to do that. Okay. So for example, we are saying here, you can see that here, unlike our Python, here we are defining the data type of query as string. Okay. All right. So in the same manner, here also we have to be careful, just like we have to be careful in case of Python. Here also we might end up sending the whole object to the RDD filter or map. Okay. The way we have extracted a variable here called query, and then we are sending that one in, okay, instead of sending this dot something. If you see here, when we say x.split query, we are basically sending the member variable called query. Okay, this dot query, which means this will get transported with the whole object. So you have to be careful. Try to extract a variable and then send it to the in the function being passed. All right. Now, those who are looking for Java functions, so the only part which you need to understand clearly is, one, what are the libraries to use when we are doing Java? Second, how to pass a function to filter and map and other transformation and actions. Okay, so passing Java functions could be in three ways. One is anonymous inner class. Okay, anonymous inner class, and second is named classes. So we used the named classes example earlier. Then third way is using a lambda expression. It was introduced in Java 8. All right. So Java function passing with anonymous inner class could be this way, where we are saying lines.filter new function. Okay, we are saying new function, meaning we are trying to create an anonymous class after extending from a class called function. This function here is a class and it's being extended anonymously at this point. Okay, it's like saying extend this class, this one function, and then create a new instance of that one. And here itself we are writing that while extending this function class anonymously, this is the function definition we are saying. We are saying public boolean call. This is the function which we are overriding, and the definition of call is return x dot contains error. Okay, so if you have been from the Java background, you could immediately look at understand this, because if you remember, we could create the anonymous classes by using new keyword on an interface or on an abstract class. Okay, so you can see that this was the method which we used earlier. Now you can see contains error implements function, and then how does it implement? By implementing a method called call, and this is the actual work that is being done. It's returning x dot contains error, which means if x contains error, it will return true, otherwise it will return false. Perfect. So here we are saying contains error has a method called call, okay, that we have implemented after implementing this interface called function. Okay, so contains error implements an interface called function, and then provides the logic of this call. All right. Now you can see that this is the data which we have loaded from somewhere, and then we are saying lines dot filter new contains error. Now you can, what is important here? This has got a name, which means the contains error could be used at as many places as we want. All right. Now the same thing from here till here is in the previous also new function this, and we are implementing the function called call by providing its body. All right. So these are the two ways of execution. The problem with this method is that this particular logic cannot be used elsewhere, while this one, new contains error, could be used elsewhere as well. All right, because there is no name for it in the earlier method. Similarly, since if you compare these two definitions, they are too verbose, too much of typing, and in case of programming, if there is too much of typing involved, developers or programmers avoid those kind of approaches. Therefore, Java 8 came up with the lambda function. It's an anonymous function declaration, all right, which can be passed. So here, lines.filter, we are creating an anonymous, we are creating a lambda expression saying, given s as argument, return this. So now you can see that lambda expressions have made the life really, really easy. Yes. So, question from how is that function interface can pass multiple arguments and return a value? Yes. Okay, I'll show you that. So it could be considered like this. We could write it in a way. We could say class contains error, okay, implements function, and here what we are saying is string and boolean, okay, and then we implement our class. So here we could add more variables. We could say string comma string, and in this case you will have to write a function called boolean call, and then we'll have string s1 and string s2, okay, and we will return some boolean value. Okay, let's try to indent it properly. Okay, makes sense to you now? So you are right when you say that? Good, very good questions. Okay, thank you, Hao. All right. this is what is it that we're talking about. All right, we're done. So if you can see that this is the lambda expression. It's probably the most simpler one out of all. All right. Urban says that so all functions in Java need to implement function class and need to implement call method. Yes, which always return Boolean. Not necessarily. Not necessarily. Okay. Okay. Only for only if you are trying to run create a filter function. Create a filter function. If you want to create a function, say, for mapper, okay, for example, let's say you're trying to create a map function, okay, you will have to say, sorry, you'll have to put a comma here, you have to put a comma here. Let's say you're creating a function called square root, okay? Okay, in those cases, what you have to do is you have to return here the double, and let's say the argument here would be, again, let's say integer. So this one would take integer, and here we will return math.sqrt and int x and x, and here we are returning double. All right. All right, does it make sense to you? Now, in the, let's say there are numbers RDD. We'll say numbers RDD.math, and we'll say new square root. All right. Brilliant. All right. So we're continuing with our transformations discussion. We talked a little bit about actions. We talked about the catch in actions, what are the things you have to be cautious about. We'll talk more about actions and transformations as we go throughout the Spark. Okay. The other common transformation is sample. Sample with replacement, and okay, you can say that after taking out a sample, do you want to put it back or not? What does sample do? Sample basically gives us a small sample of the whole RDD. Let's say you are doing a quick analysis of data. You want to figure out how does the data look like quickly. So, and you don't have too much of time to do all kinds of big data journey. So you may look for a small sample of the data, or you are in resting mode. So you're in a testing mode and you are not sure about the algorithm and you do not know the characteristics of the data. So you would prefer to pick up sample of the data and do the qualitative analysis of the data before running the code on the main data, because if you run on the main data, it might consume a lot of resources from the network, as well as it might take long time to finish, and therefore the initial analysis might take a very long time. All right, so you might want to pick up the sample of the data, and how do you do that? You basically take an RDD and say rdd.sample, and you pick up a fraction of it. Okay, you can say you want to put it back by saying first argument as true. Okay, Put it back means that the same, uh, while creating sample, it is going to give us, it's going to run again and again. If we say put back, that means there could be duplicates in the sample. Okay, there could be duplicates in the sample. So let's try to run it. All right, let's try to run the web console. And let's run our PySpark. Okay, so let's try to load this. So this sequence is containing, say, 100 numbers right now. We could say sample, and we could say true, and give us 0.1% of the total sample. Okay, so here we say this is our A. A is another RDD, you can see. The first one is a parallel collection. This is a Python RDD. Now we can say a.collect. Okay, now a.collect gives the same result multiple times. Let's check that. So it gave us this, and then we said again. So it is giving us the same result. All right. Now this time it is different. So unless you say sample again, it won't make a note of the new change. So when you say sample in RDD, it creates a seed and will remember that seed. And based on the seed, the new combination is generated. All right. Now this time you can see that there is a repetition in the data. You can see the repetition. 5 has been repeated twice and 12 has been repeated twice. Okay. And also please note that it's not necessarily going to be those many records. All right, just give me a second. All right. So you can see that when we when we said true, which means there could be a duplication in the numbers. All right. So question from Arpan is, what is seed? So seed is generally when we create a sample or when we create a random number. Every time the random number is created, there is generally a seed for the random number. Okay, and the seed is mostly based on time or something like that, so that a random number is fairly random. Okay, so seed is that one, and seed decides whether the random number is going to be same or different every time you call this function. Okay, if the seed is same, the random number is going to be same. So if you had used any other library, so whenever we are creating a random number, it gives a facility to pass on the seed, or it will assume some seed. Okay, so seed is required for creating the random number. Here point one is total fraction of the data. We are saying give me 10% of the data. Okay, point one means 10% of the total data. Okay, here it means 10% of the total data. False means we are not letting the data being replicated, duplicate, meaning whatever we pick up from this. So how does it work is it picks up records from sequence in a random fashion, and it keeps on doing it till we reach 10% of the records. Okay, and if we say true here, it will put the data back into sequence and then draw it again. That means there could be duplicates, right? Yes, we don't have 10 items, so it's an approximation. When we say give a sample, it's not necessarily exactly 10 records. All right, good, Greta. All right, so every time you call the sample and then the collect, you will get the different result. But every time you call only the collect, the result will not be different. Okay, you can see that. I showed you earlier. If you keep on saying a dot collect, now if you see keep on saying a dot collect, every time it will be the same result. You can see that. All right. All right. Now, the other important aspect of an RDD is the partitions. How many partitions does our RDD have? Partitions means portion of RDD on a machine. Okay, if you have three machines and your RDD is distributed on all the three, we call that RDD has got three parts or three partitions. So here we are saying RDD equals to SC dot parallelize, and here we are providing, we are telling Spark, we are forcing Spark to create number of partitions as 2. If you want to enforce that, hey, I want to keep 2 partitions or 3 partitions, we can enforce that on Spark. Okay, partitions do not necessarily need to be on different machines, but it is up to Spark how it will arrange the partitions. Okay, so you can force Spark to have the number of partitions of your choice. So you can see RDD dot get, what was that function? dir RDD. So there will be a function called get partitions. Yeah, get number of partitions. So we can say RDD dot number of get number of partitions. So it is returning true. All right. All right. So there's a question from Arpan. Question is, so the number of more partitions equals to more executors? Yes. Yes. Generally. Okay. That makes that makes it more possible to break down problems to multiple executors. Okay. But it does not guarantee that. It does not guarantee. It just says that you have made my life easier by giving us more partitions. Okay. So Spark will have more choice. So if we have multiple partitions, does that mean each partition will have its executor? Uh, not always, but yeah. So question from Arpan is, what is the default number of partitions for an RDD? It it tries to create the number of partitions based on the available executors. Okay, let's say the one which we did earlier, what was that one? Let's try to see how many partitions were there. What was the previous one? Let's pick up the sequence. There were 100 elements, and there were 6 partitions. All right, let's try to create really big, uh, let's say this one. Okay, sequence has got how many elements? This one, and all right. Okay, the bigger earlier number it could not fit. I was trying to create a lot of data into the memory. All right, see, it has overflown. Okay, let's try to do something smaller. Now, if we say get number of partition, now the partition is still 6. If we have smaller data, then get number of partitions is still 6. Okay, interesting. So the default number of partitions is governed by how many nodes do we have in our network. And right now, how many nodes do we have in our network? Okay, let's try to look at Ambari. Ambari is the one which is an administrative console which shows us what's going on in the network. So here you can see the total number of nodes right now which are live are around 6. You can see 6 data nodes, and there are, if you go into Yarn, there are 6 node managers. Correct? You can see 6 by 6. All right? So coming back to it, so every every array or every RDD has got partitions, and the default number of partitions is equal to the default number of nodes. Okay, you can force Spark to rearrange the partitions. You could force Spark to have lesser number or more number of partitions. Okay, and based on that, if you have more number of partitions, then one of the executors will have more than one partition, and and in case you have less number of partitions, then the one of the executors or one or more of the executors may be free. All right. Therefore, okay. So when your data is arranged in partitions, one partition on one node, second on second node, and third on third node, sometimes you want to just operate on partition label, okay? Because that is the definition. Each partition is is something which is together. So let's say you just want to combine the partition existing on each node, because that would not require too much of data transfer and it's very efficient. So maybe sometimes you want to operate only on partition basis, and there are transformations and actions which let you do that, which let you which let you operate on each partitions. Okay, so for example, there is a function called map partitions. Okay, map partitions. What does map partitions do? Map partitions would basically compute the map partitions would run your function against each partition. All right. For example, let's say you have got this function called f. This function called f. And what does this function do? This function basically sums up whatever is provided to it. It is provided an iterator, and it is basically returning sum of all the values in an iterator. Okay, so when we say map partitions, it basically run run this function against the whole partition. So to this function called f, you will get the full partition to be passed as is. And now this map partition basically combines all the records and return you the value. So imagine that 1, 2, 3, 4 has been partitioned into two partitions. First partition as 1, 2, and second partition as 3, 4. And when f is executed against partition, means the whole partition will be passed as argument to f. So the when first partition is passed to the argument as to the f, then f will get 1, 2, and then the 1, 2 can be it will return the sum of 1, 2, which is 3, and 3, 4, which is 7. Okay, let's say you want to combine the elements in each partition. Let's say you want to combine elements in each partition. You can do it very easily. For example, here, this f function which we have created is iterating over the values and converting them into a string and concatenating them. If this has 3 partitions, then you might get this kind of result. So you could say rdd.map partitions, and we say f and collect. Make sense to you? All right. So a question from how is collect function is like flat map? No. Collect basically brings all the records back to you. Okay. Collect basically convert an RDD into the local array. Okay. So a question from Arpan is, if we write just the map, does it run against partition? No. It runs against every element, single element at a time. Map partitions, when you say map F, F will get only one value at a time. Okay. F will get only one value at a time. Okay. While in case of map partition, the function would get the whole partition at a time. Yes, collect is a Spark function. The question from Arpan is, what is the use case? Can anybody guess what is the use case of map partition? Use case of map partition? Anybody? Yes. House is aggregator. Okay. All right. I'll take a step back and try to explain. Let's say there is this big array. Okay. It has got, say, many elements. I'll try to mark elements as with, say, this has got many elements. Okay, these are the elements. It has got many elements. Now let's say it has got partitions, first partition, second partition, and third partition. All right. So when we say map, when we run map, what happens is the function, whatever function you have, it is run against every element. It is run against every element. And you get the results. Again, similarly, this whole thing will get executed. This function will again executed against every element. The argument you get is a single element. Okay. So it will run again and again. You can think of this way. I'm not great with drawing. So map function, when we say map over RDD, this function will get executed against every element. But if you say map partition, when you say map partition, so what would happen is that this function called f is going to be executed going to be executed against all of these variable elements in a way. Okay. Okay. So if you say map partition and say function f, it's going to be executed only thrice. While if you say map, this function going to be executed equal to the number of elements we have here. All right. All right. And when we do reduce, okay, when we do reduce, what happens is these elements, whatever we have here, these elements, whatever we have here, these elements are reduced two at a time, like this. Okay, they will combine together like this, and so reduce function will convert two element into another element like this. All right, like this. And then again, these elements, this and this, okay, like this. And effectively, you will have okay, so this will keep on going. The whole process will keep on going unless a single value emerges. Okay, unless there is a single value that emerges like this. Okay, so finally things will look like this. Okay, so this is something, the output. This is how what happens in case of reduce. So you have this function which converts two values into one. It takes two argument, returns one value, it takes two argument, returns in one value. Same function will be applied again and again, and you will get a single value. So this is how the reduce looks like. This is reduce. Now you can see how bad. All right. Okay. So this is how reduce looks like, and this is how map looks like, and this is how map partitions looks like. All right. Now coming back to the reasoning, why would we like to do the map partition? If you want to only operate on the elements of a partition, okay, then you will first, you would like to basically go for map partition. Let's say you want to combine together all the elements on every node. Okay, you want to combine together all the elements on every node. Then then you can do a map partition. All right. Okay. So when calling the function is not too expensive, then you can go with reduce and all of the array will become a single value. Okay. But all right. I'm actually still trying to figure out what could be the case where we could utilize map partition. Okay. So map partitions is great when the cost of sending the logic to individual node is high, but operating on multiple values is low. So if you see in basically we have combined only the partitions. Okay. In those cases, if we just want to operate on the partitions, we want to uh, we want to do various kinds of operations. I'm yet to figure out a real use case of map partition. As we go on, you will understand this part. Okay, you'll understand this part, and maybe I'll get a better use case as we go on. All right. So Sachin's suggestion is you could use it for conditional weighted average use case. Mm-hmm, mm-hmm. All right, maybe, yeah. All right, I think I got a great use case. Okay, so the problem statement to all of you is find a line containing a text. Okay, find a line containing name Sandeep in 1 million text, 1 million lines of text. Okay, let's say this is my problem statement. I just want to find the first line. That's it. The first line. Okay? If you have to do this, what will you do? Any suggestions? You have been given really big text file in HDFS and you have to find out a line containing this particular keyword. It's a standard. You call it grep as well. It's a different grep. It is the objective of this kind of thing is we are just looking for only one first instance. Only first instance. What will you do? Okay. One other alternative could be you could use filter method. You could use filter method, but it will run against each value. Okay. So, all right. Let me try to show you. Let's say we are going over this from this to other side, and the moment we found here, we can stop traversing this much. So at least we could avoid traversing 1/3 of the records. Okay, the moment we found in the first one, we could stop traversing in the rest of it. All right. The suggestion from Arpan is have a global variable called age Sandeep found and write a function lambda and run against RDD. Good suggestion. And yes, good suggestion. But the global variable does not work, does not work in case of in case of in case of distributed computing, because the logic which you are sending to lambda via lambda or any other filter function, okay, it will run on multiple machine, and these global variables cannot be propagated like this. They are mostly propagated in a read-only format. In case any of these nodes try to change these global variables, it will change only on that node. It won't be propagated to other nodes. Okay? All right. The global variable which we have in case of Spark, one is accumulator and other is the what do you call the broadcast. Both are kind of one directional. All right. The okay. So one such example where we are trying to find Sandeep in a million lines of text, I have given that in my blog, where the interview questions blog. In that, we basically have given a better approach than the map partition. So in case of map partition, we can stop processing remaining partition if we stumble upon, if we find Sandeep. Okay? Does it make sense to you, Arpan? Sachin? Okay. So inside the function, we won't be able to stop all the executions of f. Here you can see, in case of map partition, let's say this function contains this logic that if line or if element contains Sandeep, it will return. So although we won't be able to stop the other functions like this one and this one, but we'll be able to stop at least one partition. Okay, did it make sense? No? Let's say Sandeep exists in the first one here. Okay, Sandeep exists in the first one. So parallelly, the three executions will start. The two will continue, but the first one would stop. Meaning we'll skip searching in these three records. There's a slight optimization over what we're looking for. Okay. It's a slight optimization for the situation which we are trying to solve. It's a slight optimization. It's not like a big deal. All right. If I get a better example, I will talk about it again. All right. All right. Keep these questions here. Have I kept a good question? Yeah. We'll address it again. We'll just mark it like to do, and as we go ahead, maybe I get a better example. But yeah, the map partition does a little bit justice when we are looking for the first occurrence of a string. Right? So map partition is clear to everyone. This function will receive the whole partition and it function will be executed how many times? Anybody? F will be executed how many times total? When we say map partition F, how many times F is going to get executed? That's correct. Once for each partition. Thank you, Arpan and Shekhar. And in this particular case, yes, thank you, how? It's going to get executed twice. Brilliant. All right, moving ahead. Here it will be executed thrice because we are, while parallelizing, we are saying that execute it, make three partitions of it. All right. Okay. So, all right, we would like to take a break now. Break for 10 minutes. Back by 10, 1, 8. All right. So should we start now? Is everybody in? A question from how is it any possible to access your Google Drive with course related material? Actually, everything is shared over that the same thing has been shared to you over the in the LMS, so you don't have to worry. All right. There's nothing extra left this side, so everything is shared there in the LMS. All right. Okay. So in case of Spark, Spark provides us many more functions on the data, not only the MapReduce. Unlike our MapReduce framework, where we could only write our logic in terms of map and reduce, and we could chain multiple MapReduces one after another to get the results. So in the case of traditional MapReduce, this led to this whole chaining of MapReduce led to the inefficiency overall. The performance was not great. And that's where the Spark comes in. Spark says that I'll provide you more and more functions so that you have more power and therefore you can optimize things in a far more better way. Okay, so it provides you many more transformations than only the MapReduce. Okay, and it is up to you when you want to pull it, when you want to execute the process. Okay, so here you can see that there is another transformation called sort by. Okay, it sorts an RDD by the given key function. So this expects this kind of transformation expects the elements to contain a key. All right. So here we are saying that so here is an RDD where each element is a tuple. You remember our tuple discussion in case of Python? Whenever we put in the round bracket, it becomes a tuple. Or it could be anything. It could be another object. It could be another array or whatever. So this is an RDD. This is a normal array which we converted into an RDD. And this returns an RDD. We are saying RDD dot sort by. And here is the function which decides on what key to be supplied. Okay. So sort by accepts a function. Okay. That function keeps on giving the keys on which the RDD will be sorted. Okay, so here we are giving the keys as the 0th element, which is this. All right, which is this. And based on this, the data is getting sorted. So first, one is the character. It's not the number. Therefore, 1 comes before, 2 comes before, A comes before, B comes before D. All right. So we are saying sort my elements by the 0th element of the tuple. That's what we are doing here. Given the tuple x is returning x0, which is the 0th element here. Okay. So this function is responsible for handing over the keys of the elements in this RDD. And based on that, the RDD will order the data. Okay, we'll talk about key value RDD again after some time, but till then, understand that sort by provides you a way to sort the data. Let's try to do some more nice things. All right, let's try to. All right. So here we have okay. So let's start our PySpark and let's try to load this. Okay, this is our RDD. Now, if we say, let's say we define a function which takes an element and returns its key. Okay, let's say we are returning the string like this. Okay, so whenever we give any number, it returns. All right, we forgot to write return. Okay, so whenever we give a number to it, it returns a string corresponding to the same number. Now, let's say we had this RDD which is made up of these numbers and we want to sort it lexically. You know what does it mean by lexically? Lexically means 10 comes before 2, comes before 21, and then comes 3, then comes 4, and then comes 5, as if they are in a dictionary. All right? The way the alphabets are arranged in the dictionary, in the same way. Okay? Not numerically. So if we have to sort this data, okay, if we have to sort this data by the string, okay, then we could simply say rdd1 dot collect. You can see that. Now let's say we wanted to just sort it by numbers, okay. We'll say fx return x. All right. Now we will say rdd dot sort by f and then we say collect. All right. Let's see what happens in this case. See, this time it has done the numerical sorting. 2 is smallest, so it is before. Now let's say what you're trying to do is you're trying to do the reverse sorting. So, okay, so in that case what we are doing is define function and we are returning negative of it. Okay, so the bigger the number, the smaller is the negative of it, right? Therefore, now this time we will get the inverse sequence. You can see that? Is the sorting clear to everyone? So if we have to sort the data explicitly over multiple nodes, we could use sort by function. All right? Okay. All right. Now, apart from these map, reduce, and filter, map, filter, sort by, map partition, apart from that, there are certain set-based operations which are very common, and those are very useful. Okay, set-based operation such as distinct, union, intersection, and subtract. Those kind of functions are also provided by Spark. Okay, so those kind of functions are also provided by Spark, and but the important part to notice is that these are pseudo set functions because they assume that your RDD contain distinct elements. Okay, they assume that the RDD contains the distinct elements. Okay, because the definition of RDD does not enforce the distinct elements. Therefore, it is not ever guaranteed that the elements in an RDD are going to be distinct. It is up to you, up to developer to make sure that before running the set-based operation, you have all the elements unique. Okay? So the operations like distinct, what does distinct do? You can find out the distinct values of an RDD. This is important because in case you're not sure before starting the set-based operation, you can start with distinct. Then you can do union. Union means, I think we have already given you an example. Union combines the records or the elements of one RDD with the elements from another RDD. RDD1 dot intersection RDD2. It finds the common common values. Okay, common values between RDD1 and RDD2. RDD1 dot subtract RDD2 gives you the only the elements which are not there in which are extra in RDD1. Okay, so those are the things you have to keep in mind. Uh, those are the functionalities which are provided by Spark with respect to the set-based operation. There are more functions which we'll talk about. Okay. So distinct gives kind of a set property to your RDD because it makes the element distinct. Also, distinct is expensive because shuffling is required because you cannot compute distinct so easily. The best way to compute distinct given a list of items is by ordering them and then removing the duplicates. And this process of ordering and removing, basically the process of sorting is quite expensive. And then union simply appends one RDD to another. It is not same as the mathematical function. It may have duplicates. Okay? Union is not like our mathematical function. Union is more like the database union where we take the data from both the sides and append them. Intersection find common values in RDDs, and subtract basically returns the first RDD, removing the second elements from the second. Okay, removing the elements which are there in the second RDD. Now there is another set operation called Cartesian. Cartesian basically gives us all possible combinations. For example, RDD1 is made up of user 1, user 2, user 3. And RDD2 is made up of venue, beta brand, ASA-T, and ritual. Now, if you do the Cartesian of RDD1 and RDD2, you will get an RDD of tuples. This is another RDD of tuples which contains first value of the tuple is from the first RDD and second value of the tuple is from the second RDD, and all such combinations will form the whole RDD. Okay, so these are set based operations. All right. Now, quick question to all of you. What will be the result of the following? Anyone? That's correct. How? It will be, yes, brilliant. It will be A, C, and B, not A, B, C. I'm not sure why it's A, C, B. I think it should be A, B, C. Let me try. It should be A, B, C. It's not A, C, B. Why would it be A, C, B? Oh, it's B, A, C. Interesting. Why would it behave like that? Any suggestions? Interesting. It says BAC. Mhm. So when I say B dot collect, after parallelizing, what it did was it did a distinct. Okay, okay. Mhm. All right. So Arpan's question point is that maybe it's using has set to do the distinct. Yes, that could be one possible reasoning. I'm just trying to figure out, let's say we have D, we have E, and then we have D, and then we have F. Then what would be the result? All right, I think I got the answer. I got the answer, I think. All right, so what would it do is it'll have three partitions or two partitions, and then in those partitions it will first compute the distinct and then would try to see the ranges. Okay, try to merge them and shuffle them. All right, all right. It will basically involve shuffling, and individual partitions will be sorted. Individual partitions will be sorted, and there will be shuffling amongst the partitions so that individual partitions make sure that there is no duplication of data. All right. All right. Questions to you. What will be the result of this C dot collect? Anyone? So we are saying A equals to an RDD prepared out of an array A, B, C, and then B equals to the distinct of A, okay, and that will be A, B, C, and then we are loading A1 A1, which is AD, and doing the intersection of AD and ABC. We are saying intersection, not union. Agree there? So it will find the common between the two and give the intersection. That's right. It will be A. Perfect. So everybody is doing good. Good. All right. All right. Now, anybody? All right. We have a good question from Sachin. Question is, what would be the result without distinct? Result is going to be little, what do you call, unpredictable. So what he's suggesting is, what if, what if we do not have distinct? What will be the result? Okay. All right. The result is correct, although not bad. All right. So the result of the following is B equals to, after distinct, it will be ABC, and A1 equals to AD. And when we subtract AD from ABC, we are left with BC. All right? Good, good. So luckily, in our case, when we are doing the, without even doing the distinct, imagine that we had to this, okay? Or let me try to do here. Let me see, like this, okay? We have two B's. Now in this case, the answer should have two B's in the output. You see that, Sachin? Okay. So I've removed distinct. In the earlier case, also, earlier as in the one previously, this one, the one for the subtract, or the intersection. All right, what he suggests is for this one. This one, it won't do anything. It'll just bring back whatever it was. Whatever we gave it, in case of this, it'll just bring back whatever we give it. Let's look at it. Okay, so we say a dot collect, and we will have the same values what we have given it. No sorting, nothing. Perfect. Perfect. Now subtract is done. All right, quickly, anybody? We are saying, this time we are saying, did we delete something? All right, we did not delete. All right. So what will be the union quickly? Okay, Rahul says it is going to be AABC followed by AD. That's correct. That's correct. It is going to be this way. All right. And this one, we are saying A equals to an RDD out of ABC, and then we are unioning it with AD. So we are basically saying union this with this one. Haven't we already discussed it? Yeah. Unioning B with A1 after distinct. That's right. It is going to be ACBAD, or it could be ABCAD. All right. Next is, what will be the result of the following? Yeah. That's correct. Adjective will come first because we are saying adjective then Cartesian. All right, let's take a look. You can see good boy, good girl, and this is basically a tuple. Each of these is a tuple. That's more important to note. Okay, so it basically created tuples by combining each word from the first RDD with each word of the second RDD. Okay, good, very good answers. Now moving ahead. Now comes the important function called reduce. Okay, so reduce is an action, and reduce runs on the whole RDD you a singular value. Okay, and as I have already given you the example that what exactly happens in case of reduce, this function, the most important part to understand is the function which we are going to pass to reduce function is going to take two argument. Okay, so reduce aggregates elements of a dataset or RDD using a function. This function takes two arguments and returns only one. Okay, it converts two values into one. It merges two values into one. And using this function, the reduce function will reduce the whole RDD into a singular value. Okay, the important part to understand is that this function has to be commutative and associative for parallelism. Otherwise, it wouldn't make any sense. Also, the return type of this function has to have the same data type as the argument being passed to the function. Why? Because the output of the function is going to be the second call, the input to the second call. You can see here, the output of the same function is the input to the next level, and so on. Okay? All right. So let's try to see how this function called sum, which takes two arguments and returns only one, converts. How does this convert the full sequence of values into a single value? Okay, let's try to see. Okay, so you can see sum 4 comma 5 is 9. You can see that. Now total is here. So it has computed the sum. And important to note is this total is not an RDD, it's a local variable. So the sequence is an RDD. On this sequence, when we executed a reduce function called sum, it again and again applied this reduce function to convert the full RDD into a single value. And this single value is the summation of all the numbers. Okay? All right. Question from Arpan is, why are these elements in square bracket? Square bracket means array. Round bracket means tuple. And curly bracket means object. Okay. So an RDD is generally an array. The key values are a tuple generally. An object we all know. All right. Now let's try to understand what happens in case of reduce function. All right. Now the important part here to notice is that in case this contains multiple values. Okay. So how should I describe? Yeah. Here the important part to understand was that imagine that it has two partitions. Okay. It has two partitions. Now the dynamics will be fairly different. Okay. Dynamics will be fairly different. Okay. All right. How can I? All right. Let's take a look at it. All right. So what is important is if this has two partitions, okay? If this has two partitions, then these two values, each partition is reduced to a single value by calling this function again and again on the whole data set. So once this whole partition has been reduced to a single value, similarly, this partition, second partition has been reduced to a single value, then these two values are brought locally on the driver node, and there the function is executed again. So this function which you see here is being executed locally. Okay, this function which you see here is executed locally because these two values are the end result of each partition, and they will be brought to the local machine. So here, from here, this portion is happening locally. All right. All right, that is most important to understand. I'll give you another example. Let's imagine for now that we are trying to compute the line length, the length of the line. That's what we are trying to compute. Okay, so let's see. Had it been a single node, the sum of the total line lengths would be how much? The sum of this one. Okay, sum of this one. We could say sum. Okay, we'll have to start again because we have overridden the sum function. Okay, so we could say sum. It's a 62. Okay, so you can see that if we had to compute on a single machine, we would basically iterate over all the line lengths, then sum all the line lengths. Correct? Now think of it on the Spark side. What exactly happens on the Spark side? This RDD, this RDD will be divided onto three partitions if we have three nodes. Okay, let's assume that we have three nodes, node 1, node 2, node 3, and this RDD has been divided on these three nodes. Okay, so first node contains three strings, second node contains one string, and third node contains two strings. Although generally the last node contains more number of strings as compared to the first node. Okay. So when we say compute line lengths, first we will do a map, right? We'll do a map. So line lengths on each node is being computed, okay, as this one using a single map. On the same node, we have computed the line lengths. Now we are doing, we are running the reduce method, which will find out the summation of line lengths. So first, using the sum function, 11 and 9 is combined to form 20, and then 20 and 4 is combined to 24. So node 1 says the total length is 24, node 2 says it's 14, and node 3 says 24. Now on the driver node from which you're trying to execute the whole process, all the three values 24, 14, and 24 again are brought, and then again the same sum function is being called again on the driver node. Now you can see that the function, the reduce function, which is sum in this case, is being executed on every node, and once everything has finished, now the same thing has been applied on the driver node. Okay? To reduce the values from all three partitions into one. Make sense to you? Question from Arpan is, so some of the nodes reduce method runs multiple times. Yes, of course. So you can see that even in this diagram, you can see that the function reduce method is being called how many times on one partition? 1, 2, 3, 4, 5, and 6. 6 times on the first partition, and 1, 2, 3, and 4. 4 times on the second partition. And total number of times is 6 plus 4 is 10, and 1 is being called here again, which is 11 times. So we are calling this reduce function 11 times. All right? Is everyone with me? Have I confused you, or are you comfortable? Yes, it looks far more different than the Hadoop reduce because here it's more like a combiner from Hadoop. Okay, here it's more like combiner but with only two arguments slash values. Correct? Alright, so keep this in mind. Now, the problem with reduce is that it has to return the same output as the input, same data type as the input. Alright, now sometimes you want different values, you want a different kind of aggregations where there is the resulting value is different. Okay, in those cases you can use fold. Let's say you are trying to concatenate all the values together, right? So you provide a zero value which is an empty string, and in each reduce the values are being concatenated to the base. Okay, so I will try to demonstrate to you how should it happen. Okay, so this is an important idea. Let's try to show you what happens in this case. We are saying, so fold is very similar to reduce, just that the return value is different in this function. All right. Let me try to see if it works. You can see that these are the values which are gathered. So what exactly is happening? So we are gathering all the values into an array. Okay. Let's say given a full list of numbers, you want to convert those numbers into an array. Instead of using collect, you want to bring, you want to convert them into array. What will you do? You cannot use reduce because in case of reduce, when you concatenate two values, it has to return the same data type, right? Either you first convert every value into an array and then you concatenate them. Okay, so in these cases you can use the fold. Fold is basically providing a zeroth value, the ground value, to which all other values will keep on collapsing. Okay, I think I should show you in a diagram. That will be easier for you. Let me try to show it in diagram. Okay, on the same lines, let's say okay, let's say you have this kind of these many elements, and there is a partition. Let's say there are two partitions. For now, there are just two partitions. Okay? So what would happen is we provide a zero value. Let's say this is our zero value. Here also the same zero value will be initialized. Okay? Now this zero value and your value will be combined. This zero value and your value is going to get combined. Alright? Similarly, these two will be combined, these two will be combined, and then again these zero value will be combined with this, whatever is the value that comes out here. How should I describe? Alright, so let me define a zero value. So this is our zero value here. So this zero value will be combined with the first value, and whatever is the result will be combined with these two, and whatever is the result will be combined with this one, will be combined with this one, will be combined with this one, and so on. Okay, so basically we start with the zero value which is suggested. Okay, we start with that value. All right, and we keep on combining with each element, and then we get the results. So this is our final result. Okay, in a similar manner, whatever zero value we provide, zero value could be anything. It doesn't have to be zero. It could be, in the example which we are providing to you, okay, in the example which we are providing to you, the zero value is an empty array. Zero value is an empty array, and all the values are being appended to these two values. And once both the sides have reached to a final value, they will be combined together to give you the final result. Okay, so the initiation of the process, for initiation of the process, it uses the zeroth value provided to you. Okay, or how should I give a better example? Let me put this at zero value. Okay, this is our zero value, and this has got some different data type than our value. Okay, so when we combine these two things together, this and this and this, okay, we will get the same data type as the zero value, and then we will combine this zero value with this one. Okay, we'll combine this zero value with this one, and so on. Okay, so basically, and same thing would be happening on the other side of the partition. Yes. So zero value is of initial value of the return type. That's more correct, Arpan. Alright. So basically, when your return type is different from what we are looking for, a return type is different than the input data type, then we generally use fold as opposed to the the reduce. All right, everybody comfortable with fold? It took me some time to figure out what exactly is happening inside it. All right, so here our zero value is an empty array. Yes. Yeah, please feel free to ask because I doubt that all of you have got it. Okay, so in case, I'm sure there are doubts, so please feel free to ask. Arpan says that it took me like 4 hours to understand from the book. All right, so can anybody, in this example, let's say we are, what do you call, how should I, okay, so let's say we are trying to convert the whole array into strings. We want to convert 1, 2, 3, 4, 5 into a single string, which is 1, 2, 3, 4, 5, 6. Sorry, 5. We want to convert it into this. Can we use fold for this? Good, very good, Arpan. We could use we could use fold for this. Now, important thing to note is that even though here, important to note is that the same thing would be happening this side and you will get this kind of a data set. Now, here if you see the argument, one argument is of heart shape, another is of the tick mark, correct? For this function, okay? Because this function is basically combining a tick mark and a heart shape and giving us the tick mark. Similarly here, heart shape, tick mark and giving us the result. But when the results from both the sides are combined, it will be combining two tick marks. So the function has to be smart enough to handle these two different kind of data sets. Here the same function is combining a heart and a tick and producing a tick. When these two will be combined, this tick and this tick, then your function should be able to handle that part. Okay? And that was one of the problems with fold. Therefore, another function called aggregate was created. Okay? This aggregate function was created in order to overcome those kind of problems. Okay? If you see that here, Arpan, are you with me? So again, on this side also, if you think about it, this is our zeroth value to which first these two things will be combined together. Okay, and we'll get a tick mark. Okay, then a tick mark and the other heart will be combined together. Right? And then we'll get a tick mark and so on. Right? Finally, we'll get a tick mark from both the sides and we'll be combining that together. Correct? All right. Yes. So, and that's why this is very important to understand. I hope I have been able to do the justice here. That's why you see if the type of X is a list, then do this. If the otherwise you just append. Okay? Meaning if type of X is a list, that means X is also an array and Y is also an array. And if and that's why we are saying Y dot extend X. If y is not an y is an array and x is x is not an array, then we can simply say y dot append. That's why there is a conditional statement here to handle the last statement, to handle the last situation here, where both the sides have two tick marks and we are combining two tick marks instead of a heart and a tick mark. Okay. All right. Now, extend method extends one array list to include the another. Okay, I'll show you this. So if we have 1, 2, we can say append 3, right? And we'll get another array. So we have A equals this, and we are saying A dot append. So you can see A has become this, A dot append 4. Now you can see 1, 2, 3, 4. All right. Now, let's say we want to extend it to include another array. Let's say 5, 6, 7, 8. Now we will have this because we can't do append on this. If we do append, it will look awkward. Let's say we say append. Now you can see the last element is an array. You can see that. All right. Is everybody okay with this? No. It's basically a little different reduce where the output is different from the input. The output data type is different from the input data type. All right. So the problem which we just faced was when we were merging the two partition. Okay. Right. So these kind of situations were specifically handled by another function called aggregate. First, all the values of each partition are merged to the initial value using sequence op. Okay? And then and then all the partitions are combined together using combiner op, which means that this operation where we are trying to merge two tick marks together, it's a different function. While it's f here, this is, let's say, f1. Okay? While these are all f, here it's f1. Okay? So you can provide two different functions, one for combining the resultant value from each partition, and one, we can provide two functions, one to combine all the values of a partition into a into a zero value, and we could provide another function to combine the resultant value for each partition. Okay? All right, I think I have put everybody to sleep. Breather. Let me check. Arpan, Hao, Rahul, Sachin, Sekhar, and Valentin. I hope I've not put everybody to sleep. Okay, so yeah, looks like everybody's awake. All right, all right, good. So everybody's awake. Okay, so keep asking questions because so even if you're trying to just understand, keep on asking questions because that probably others would also be struggling with the same idea. All right, so main challenge we faced with reduce is that sometimes we have to aggregate value, combine value not such that the output is having different data type than the input. Okay, in those cases the reduce could not be used, and therefore there was a need of a different function. So the fold came into play. All right, although at first it looks like the fold has made everything like a chain. Okay, but that's not the case, because here, while first one is being operated on, the second one could also be operated on. Okay, it's not that we will be using only the zeroth value to combine. The other one can also start processing parallelly. Okay, so that's the idea. So aggregate is far more useful as compared to the reduce or fold. So all the values in this are first merged with the initial value to produce the results, and then the combiner operations are executed. Okay, and then we get the result. Is it clear to everyone? All right. So Arpan's question is, can we say that it is same as fold except that it has a different logic to combine results from all partitions? That's right. All right. Can we do an example like fold? Let's try. All right. Let's try exactly what we did in case of fold. Okay, so we define one function called f1, which takes two variables like x and y and returns y dot append x. Okay, so this is the function. Let me just name it, and the name is sequence op. Sequence op. Okay, we basically appending our variable to an array. Now we define another function which is called combiner op x comma y, which is return y dot extend x. Okay, and then I have already written here. Okay, all right. We already have one example. I think we should take this one first. So look at this. What are we trying to achieve? We are trying to achieve is we want to concatenate the values in a partition using colon, and then we want to combine these partitions using semicolon. Okay, we want to do that. So let's try to demonstrate that if we can here. Okay, so we have got V, and let's see what is there in the V. You can see that the different partitions, there are 6 partitions right now. Okay, there are 6 partitions. I can show you the partitions. So in sequence we have sequence dot get number of partitions 6, correct? And those are the 6 semicolons you will see. 1, 2, 3, no, it's far more than that. Okay, so the result is this. This is redundant. All right, one partition, second partition. So there are empty partitions as well. Okay, what have we done? Yeah, so plus represents the, okay, plus represents the, all right, I think I get it, what's happening. All right. So plus represents the 0 value. So first of all the values from each partitions are going to be merged to plus. Okay, all the values from each partitions are going to be merged to the plus, and then we are going to merge them using semicolon. Okay, we're going to merge them using semicolon, and that's what is happening here. All right, that's what is happening here. Are you comfortable with this idea? All right. No. Arpan says he's not comfortable. All right. Let's try if we can do. So basically, there is a function called sequence.coals. Let me try doing the coals first. All right. So this is our RDD. Okay. This will give you more clarity in terms of what's happening. Let's imagine that this is our RDD. Okay. And we are trying to use this. Okay. And we get this. Now let's walk you through this. So what is our zero value? Our zero value is plus, and values from the same partitions are being concatenated first with the plus, which means we got this. Okay. And then 2 and 3 got merged together with plus like this. Okay. Then 4 got merged with the plus like this. Then 5 and 6 got merged with the plus like this, and so on. All right. Just that there are these extra empty things. 7 got merged with the plus like this, and 8 and 9 got merged with the plus like this. Okay. And then all of these partitions are merged together. All of these partitions are merged together with a semicolon and a plus. All right. So here the more important part is one more thing which we used just now here is sequence.glom.collect. What does it do? It basically converts the it, it it basically creates an array of arrays. Each individual partition is an array and so on. Okay? So you can see here. All right. All right, everybody comfortable with the idea? All right. So we will continue our discussion again. Do not worry about the the completion of the course and this and that. We will focus on the ideas which are more important. Okay. GLOM method basically combines all the records into one and displays the partition using the array. Okay. So GLOM basically gives us all the values of a partition in an array. All right. Question from Giridhar is how do you order the number of numbers in descending order while displaying on the screen? You will have to use sort by function. Sort by array, and there so sort by the RDD dot sort by, and then you say collect. Okay, here there will be a function, sort function, which will look like this: define f, x, and return minus x. Okay, this will give you the what you're looking for. All right, Greta, you can try this one. You first define a function which returns a negative value, and then use that function for sorting the values. Is that what you're looking for? Yes, we can pass lambda instead also. Good happen. All right. Thank you very much. So please finish the assignment which is there in the session. We have added few more quiz questions. So please finish this quiz and this quiz. Okay. There's a Python subjective quiz as well added. And try running both Java code, Java example, and Python example. All right. So that's the assignment for the next session. Before the next session, okay. All right. Thank you everyone. I hope you are having good time. Please feel free to give me a feedback. I'll go through the feedback after the session. Please provide the feedback so that we can try to improve as much as possible. All right. Great. Thank you, Arpan. Valentine's question is, next session is on January 16th. Yes, it'll be on, not on January 16th. Yes, it'll be on January 16th. Yes. All right. Good, Arpan, that you found it useful today. All right. Great. All right. Thank you, Arpan. Thank you, Hao. Thank you, Rahul. Thank you, Sachin. Thank you, Sekhar. All right. Have a great day. Bye-bye, Gridhar. Have a good day.